Okay, we rotate another integral from the UNSW Integration Bee 2024. This was round 2, problem 12. We have the integral of 1 over the square root of x times the square root of x times the square root of x minus x squared dx. Okay, when I first saw this, I thought maybe it was one of those like infinitely nested radical situations, but actually it's definitely not infinitely nested. We really just have 3 x's right here, and we can actually just kind of combine these and simplify it. So what I'm going to do to start is actually let's go all the way to the innermost term. So what I'm going to do is just taking this, I want to get it out of the radical notation, so I can write this as x times x to the 1/2. Multiplying, we can just add exponents, so this actually becomes x to the 3/2. But then putting this together with everything else here, we have this other x in front. So this is going to be x times this x to the 3/2, but this is inside another square root, so I can write this as a 1/2 around it. With exponent properties, I can multiply that in there. So what we end up with, multiplying the exponents now, we end up with x times x to the 3/4. But multiplying again, we just add exponents again. 1 plus 3/4 gives me x to the 7/4. So then from here, we can take this and put it back into our integral. So this is going to transform. This kind of simplifies pretty nice because now we just have x to the 7/4 minus x squared. But then for the squared, I'm going to get this as a common denominator. I'm going to write the 2 as just 8/4. And what that's going to allow me to do is now I can just factor this. I'll factor a x to the 7/4 out. So we'll factor this as x to the 7/4. And this is going to become 1 minus x to the 1/4. But now this whole thing is under a square root. But then when I split this up, I can write this as x to the 7/4 to the 1/2, and then I can have a square root on this other piece, 1 minus x to the 1/4. But then again, multiplying exponents, this is going to become x to the 7/8 here, and then this will just be the same thing here. So then when we take this and put it back into the integral, what's going to happen is I'll bring this into the numerator and write this as x to the minus 7/8, and then this piece here, we're just going to have square root 1 minus x to the 1/4. But now from here, I'm almost ready to do a u substitution, but one thing I don't like is I've got a 4 in the denominator here and an 8 here. To make this work together, what I want to do is, I want this here on the x. I want this to be x to the 1/8, and how I can set that up is we can just write this as squared, because notice if you do this, just noticing that this doesn't change, if you multiply back in the 2, this is still x to the 1/4. And now what we'll do is we can go ahead with the u substitution, but I want to do it on x to the 1/8, so we'll say u equals x to the 1/8. Taking a derivative, we have du is going to be 1/8 x minus 7/8 here with power rule dx. And so just notice we almost have here in the numerator our du, but we just need that 1/8. So what I'll do is I'll create that by multiplying in 1/8 there. I don't want to change it, so we'll multiply by an 8 in front. So now we can just go ahead and substitute. We have this 8 that we'll bring along. This whole thing here is going to be just du in the numerator, so this becomes du. And then everything else, this is going to become square root 1 minus u squared. But this is a very common integral. This is just arctan. So what we're going to have here, this is going to become, when we integrate, this will become 8 arctan of u. And so we just need to back substitute in order to finish this thing off. And so for my final solution of this, we get 8 arcsine of x 1/8, add a plus c, and that's it. Okay, there you have it. Good problem from UNSW 2024. Thanks everyone for watching. Have a good day.